Good morning. My name is Kelly DeAndre, class of 1988, and I would like to welcome you to the Holy Cross Alumni Association's Classroom Revisited 2021. I have the pleasure of serving as the co-person of the HCAA's Continuing Education Day Committee. We're so happy to have you join us for what promises to be an educational and entertaining experience as we learn about the science behind one of our favorite beverages, wine. I hope you enjoy yourself today. Before I introduce our faculty presenter, I have some housekeeping notes. This class session will last about an hour. You're welcome to submit questions at any time throughout our presentation using the Q&A function on your toolbar. I'll return later in the webinar to facilitate your questions with Professor Isaacs. Keep them coming. Now, some words about our terrific faculty presenter. We are thrilled to be joined by André Isaacs, Associate Professor of Chemistry at Holy Cross and a proud member of the class of 2005. Professor Isaacs holds a Ph.D. from the University of Pennsylvania and specializes in organic chemistry and synthetic methods. He is also a lover of wine. We are so happy to have him with us today. Professor Isaacs will lead us in a webinar session entitled The Chemistry of Wine, a popular topic based on the size of today's audience. And now I present to you, Professor André Isaacs.
Hi, thank you so much for that introduction, Kelly. And before I begin, I just wanted to talk a little bit about where my interest in wine started. I was a postdoctoral researcher at the University of California, Berkeley. And of course, you can imagine the proximity of Berkeley to Napa Valley and Sonoma County. So I would take trips up there, look at vineyards, got tours of the facilities, and recognized that chemistry was so integral to what they did in the winemaking process. And so really got interested in a lot of California reds like Cabernet Sauvignons and Pinot Noirs. But it really wasn't until about 2 or so years ago that my interest in wine really started to blossom. And that's because of my carpool. I carpooled with 3 wonderful colleagues of mine, retired Professor Maurice Girard from the English department, who really got me interested in old world wines with his vast knowledge of French wines, wine pairing, our discussions of the terroir, and also Professor Schertzer, who introduced me to New Zealand Sauvignon Blancs, and Britt Smith from the Study Abroad department, who really got me interested in the Nebbiolo grape. I had my first glass of Nebbiolo with him. And so I just want to point out that I am not a sommelier. I am a chemist who, for the past 2 years, has really jumped into learning a lot about wine. And I'm very, very excited to share what I've learned with you and to answer your questions as best as I can at the end. Okay, so let's jump right in. What is wine? Wine is an alcoholic beverage, and it's the fermented juice of grapes or other fruit, while beer, on the other hand, is fermented grains. Wine grapes are from the Vitis vinifera species, not your table grape that you see on the bottom right of the screen here, but the Vitis vinifera, as you can see, it's a very different shape, much smaller. And the vintage really refers to the year the grapes were picked. So you can see that on your bottle, 2015, 2016, that's the year the grapes were picked. Other things I figured I'd bring to your to talk about before we jump into the material is single varietals. That's usually referred to when you're talking about your grape. You might see that on the bottle where it says Pinot Noir versus Cabernet Sauvignon. In the USA, they have different standards versus Argentina, where you need about 75% of whatever grape is in your bottle for you to call the single varietal. Oregon turns out to have the highest standards, where you have to have 90% of that grape for you to call it a single varietal. A wine blend, of course, then is more than one wine. My favorite wine blend is a Côte de Rhône, and that was introduced to me by Maurice. And that is mainly a GSM blend for Grenache, Syrah, Mourvedre, as they call those grapes in France. And if you live in other places, they call them differently. For example, a Grenache is called Grenacha in Spain, while a Syrah is called a Shiraz in Australia, and the Mourvedre is Monastrell in Spain. So wine composition, what is in wine? So all wines are on average about 85% water and about 13% alcohol. And it's the other 2 to 3% of wine that makes every single bottle of wine unique. and that's where the variety lives. And so over here on the right side of your screen, I have for you a red wine composition of the minor components in wine. And those include things like acids, acetaldehyde, a little bit of that. Glycerol is actually a higher level alcohol that's present in your wine, and other compounds like esters, sugars, a little bit of sugars, phenols, sulfites, etc. Now, it's important to know where these compounds are in your grape, so that winemakers can determine which part of the grape to use for the winemaking process. And so here's a grape, and you can see the pulp is where you find the water, sugar, and the acids that are found in your wine. The skin is responsible for the color, compounds, the tannins, and other flavors. The stalk has some tannins as well, and the seeds have some bitter oils and also some tannins. And the amount is going to be dependent on the type of grape, right? The grape genetics are going to determine the amount of sugars you have, the amount of acids, etc. Example, a Pinot Noir versus a Merlot. So the grape has all of these compounds, but if you look at a chromatogram of the grape, which is just analyzing the number of types of compounds that are present, I have two chromatograms here on the screen. You can see A and B. A represents a chromatogram for compounds in grape juice, and you can imagine that every line on that chromatogram is really representing a particular compound. And so a grape clearly has less compounds than wine. The fermented grape is in the bottom in chart B. And you can see that grape components have increased, right? The components have increased from the grape to the wine. There are over 10,000 compounds that are present in wine. And so where are they coming from? Well, the compounds present in the wine can remain unchanged from the grape. So there are compounds that are in the grape that carry through the entire process that are still present in the wine. And then the fermentation process is really what's responsible for the majority of compounds that we have in our wine. And there are two fermentation processes that occur in wine. We'll talk about them shortly. That's a regular alcoholic fermentation facilitated by yeast. And then there's a malolactic fermentation that people typically do after that fermentation that is facilitated by bacteria. So after that, we store our wine, and a lot of compounds are formed during the storage process, and we'll talk about that. The other thing that really impacts the wine components is really the winemaking process. And there are two main groups of, or categories, I would say, of winemaking processes. We have the conventional methods, which uses machinery and a lot of additives to the wine process to get you the wine, while there's this natural winemaking process where people try to minimize as much as possible human intervention in the winemaking process. And so I figured I'd talk a little bit about the winemaking process for you so that we could see at what stage of the winemaking process we could use some chemistry to influence the outcome, and also how winemakers actually just make wine. And so the first stage is the harvesting. And at harvesting, you want to make sure that your sugars and your acids are in balance and that your grape is not overripe or diseased. And handling of the grape is very important at this stage because that can affect the types of compounds that you form. For example, in a natural winemaking process, they typically prefer to pick the grapes whole by hand. And so if you're picking it by hand, the grapes are kept intact. You haven't done anything to the grape. However, if by conventional methods, if you're using a machine to pick the grapes, you can rupture the grapes, and rupturing the grapes can lead to the compounds being exposed to air, and oxidation reactions can happen. And then you have already started forming new types of compounds that will get expressed in your wine when you drink it. The crushing method is next. And during crushing, what they're typically doing is they're destemming and crushing them mechanically. What's happening now is going to be different for the different types of wine, and I've outlined here for you how they make the differences for different types of wine after the crushing and the pressing at this stage. For white wines, what they're doing is that they're removing the seeds, they're removing the solids and the skin from the must that results after the press. And then they take the juice on and they ferment just that. While in red wines, they're keeping the seeds, the solids, and the skin intact with the juice, and they're fermenting all of that together to give you the red wine. And that's important because that's going to affect the flavor profile, and you're going to get the tannins from the skin and the seeds and the color as well. Rosé, they're taking the red grapes, they're keeping the skin in contact with the juice for about 2 to 12 hours. And then they remove the skin and the seeds and so forth. And then they ferment this juice, which clearly would have abstracted some of the color compounds and some flavor compounds as well. And that's what gives it its unique rosé color. And orange wine is when they do the same process as a red wine. But instead of removing the seeds and solids from the grapes that they used to make white wine, they actually keep them intact. And then they ferment the seeds with the must, with the juice, and you can get an orange wine, which tastes a lot different from a regular white wine, because you've not incorporated the seed solids and skins. You can make a white wine from a red grape. So for example, a Pinot Noir, you can have a white Pinot Noir. All you have to do is, after you've pressed it and crushed it, just remove the skins and the seeds and ferment the juice immediately, and you'll have a white Pinot Noir, and you can buy that in the store. So alternately, you don't have to crush the grapes. There's another method that people use, and that is when you actually keep the grapes intact and you put them in a vat, you deprive them of oxygen, and what happens is that there's an internal fermentation that happens in the grape, a different process that happens when yeast is involved, and that results in the formation of alcohol. And once a grape gets to about 2% alcohol content internally, the grape busts open. And then what people do at this stage is then they will press the grape. And they will continue on the process, either by using the native yeast that is present on the outside of the skins of the grape or in the ear to continue on the process, or they will add yeast that will then continue on. So that's a really different process, because you're having two different types of fermentations happening, one that's internal to the grape and one that's external, that's affected by yeast. And this process is really popular in the Beaujolais region. A Beaujolais Nouveau wine uses this process, and a lot of other natural wines prefer this process as well. So next is the fermentation. As I mentioned, natural fermentation can start happening. There is yeast that is present, wild yeast, native yeast that's present in the ear and on the skins. But what people typically do in a conventional method is that they will inoculate the must with yeast. And the yeast people use is Saccharomyces cerevisiae. And that is what is doing the chemistry. It is converting the sugar directly to alcohol. So without sugar, there is no alcohol. And the sugar in the grapes are directly what gives us our alcohol. And the fermentation can take anywhere from 10 days to over a month to give you alcohol. And so here is the reaction that's happening. Sugar is being converted by the yeast to ethanol. And how that happens is the sugars in particular that are used are glucose and fructose, and those get transported into the cell, and those are converted then into ethanol via a very cool and long process that involves several enzymes that catalyze the breakdown of glucose and fructose all the way down to ethanol. We will not go through this crazy cycle or process, but what you get is ethanol that's generated. You get 2 molecules of ethanol for 1 molecule of sugar by the yeast, and that gives you ethanol, carbon dioxide, and the sugar is converted. Now, very important to point out that yeast really need this process for energy. So the conversion of sugar to ethanol by yeast is a process that allows them to gain energy and allows them to the population of the yeast to increase. But at the same time, it's a double-edged sword, because as the alcohol content that the yeast are producing increases, the yeast die. They cannot survive in very high alcohol environment. And so once you get to about 12 to 13% alcohol content, the yeast start to die. And then you get your alcohol, and the production of your wine, your alcohol shuts down. And this will be important once we get later on in the discussion of the sugar. A second fermentation happens, of course, and it's not always done, but this is what we call a malolactic fermentation. And that is when they will add bacteria after the first fermentation to do a secondary reaction that I will talk about later. So after you've done your fermentation, the next thing you want to do is clarification, and that is going to be removal of the suspended matter that results from the fermentation. So you want to use gravity to remove the seeds, the rest of the yeast, And then you can siphon the liquid that stays on the top over, they call that racking, into a new container. So once you've removed the gravity, remove the seeds and the yeast, you can siphon over the liquid at the top. Now, next, what you're going to do is a fining process. And the fining process is to really remove tannins and other solids that are still remaining from your wine. If you look to the left image, you'll see here a glass of wine that has some solids at the bottom. Those are condensed tannins, and they can form in your wine over time if not all of them are removed. And so to remove the tannins from the wine, they will add an agent to it. And typically what winemakers do is they add egg whites. And that's because tannins bind really well to proteins. And here in this picture at the bottom right, you'll see a winemaker literally adding egg whites to the barrel of wine. And what that will do is that will coordinate to the tannins, and that will remove the tannins. They'll sink to the bottom, and over time, they can just filter that away using filtration to get rid of the egg whites and also the tannins that are bound to it. There's some proteins that can be removed as well, and they would typically use gelatin to remove that. Once the clarification process is done, then it's time to age and bottle your wine. And you can instantly bottle it after this process is done, or you can age it in these barrels, or you can age it in stainless steel, or you can age it in a bottle. Bacteria and yeast still remain at this process after this process is done. The previous fermentation and clarification process is done. And so you want to remove and kill the bacteria and yeast by adding sulfur dioxide or sulfites, and those will kill the yeast and the bacteria. In a natural wine process, they typically avoid this as much as possible. And so what they will use is what we call cold stabilization as a way to kill yeast, and also to remove tartaric acid, which is important. I'll talk about why removal of tartaric acid is useful at a later stage. And so I'm sorry, people, for those who are not chemists, I have to, as an organic chemist, I cannot, go through a talk and talk about wine and not teach you some organic chemistry. And so for people who have learned organic chemistry, you can take the next 2 to 3 minutes to sip on your favorite wine. For the rest of you, this is time to learn a little bit of chemistry. And so what I'm going to tell you right now is that organic molecules really are very important and very common in nature and constitute the backbone of life. And that's because carbon really is the backbone of all of our molecules. And we only use major 4 elements from the periodic table that I'm showing here to the bottom left that can make over 90% of all organic molecules that we know. And those elements are carbon, nitrogen, oxygen, and hydrogen. And I'm just going to tell you that carbon makes 4 bonds, nitrogen makes 3 bonds, and oxygen makes 2, and hydrogen makes 1. And I hope you'll just accept that. And if you respect these bonding patterns and you know the formula for any molecule, you should be able to draw its structure. So for example, I'm giving you a formula, a compound here that has 2 carbons in it, it has 6 hydrogens, and it has 1 oxygen. How would we draw this structure? Well, we can simply just respect the bonding patterns. If carbon makes 4 bonds, we can draw a carbon atom and draw 4 lines coming off of that carbon. And each of those lines would represent a bond. So what we can do is we can connect that to another carbon. Here are the 2 carbons in the molecule that are connected to each other, and they're still making 4 bonds each. Each of these bonds are connected to something else, and one of them is connected to each other. We can throw oxygen in. Oxygen makes 2 bonds. Now oxygen is connected to one of those carbons, and we can fill in all the other bond connections to hydrogens. So that formula is complete. We have 2 carbons, 1 oxygen, 6 hydrogens, and they're all making the bonds that they're supposed to make, 4, 2, and 1. And this is the structure of ethanol. Ethanol, of course, is the alcohol that is present in the wine we drink. Next structure, just to give you one more example, is C2H4O2. You can do a similar process. I'll draw this one quickly, and this is a structure. Carbon is connected to another carbon. This carbon actually is making 2 bonds to an oxygen. I don't expect you to know that. And it's making another bond to another oxygen, which is making 2 bonds to a carbon and a hydrogen. And this is the structure of acetic acid, which is present in your vinegar. Vinegar is an 8% solution of acetic acid. It is also present in wine. And so this is how we would draw our molecules, and you will be seeing a lot of molecules on the slide. And so I wanted you to be able to appreciate it. Now, as organic chemists, we don't draw out our molecules like that. And that's because if I have a molecule that has 50 carbons in it, that would be me writing a lot of C's, writing a lot of H's, and drawing a lot of lines. And to short that, we have this thing we call a line angle drawing. And that is to represent carbon atoms as points. And to represent a carbon atom as a point makes it very easy because then we don't have to draw the carbon atom. And we leave hydrogens out. We don't draw hydrogens in unless they're attached to non-carbon elements. So for example, this structure here on the right of ethanol is its line angled form. And those yellow dots that you see here are literally representative of where carbon atoms are. They are the points. So we can draw a line and every point would represent a carbon. Every time it bends, that's a new carbon. So that carbon on the left is connected to one other carbon. And the other hydrogens that it's attached to are implied. They are always implied in our structure. So the left carbon is attached to one other carbon, the other dot. I didn't show you 3 other connections, but those are implied because carbon makes 4 bonds. If it's connected to one other thing, the other 3 things must be hydrogens. So likewise, the middle carbon, the second carbon, the yellow dot at the top, that is connected to 2 things. It's connected to the prior carbon and it's connected to the oxygen. That's 2 connections, which means if it's a carbon, its other connections must be 2 hydrogens to complete the 4 bonds. And so by doing this, we can draw things very quickly. For example, acetic acid, once again, the left carbon is connected to 1 carbon in the middle, which means it must be connected to 3 other hydrogens. And that carbon is shown to show its non-hydrogen connections to oxygen. This is important because if you're drawing a really large molecule like this, an anthocyanin, which is a color compound in wines, you can draw this pretty quickly. Imagine if I had to write out C's and draw H's for all of those carbons that I've shown you that are present in this molecule that I've highlighted in green. It would take a really long time. And so this molecule is an anthocyanin, and it is responsible for the red color that we see in wines. It has a lot of carbons in it, lots of hydrogens. It has oxygens as well. So that's our chemistry lesson. And with that, we're going to move into talking about the major components that influence wine flavor and smell, and also at what stage of the process they can be manipulated by winemakers. So first, we have to talk about the carbohydrates or the sugars. And of course, glucose is one example of a carbohydrate or sugar. At ripening, when the grape is fully ripe, we have a 50-50 a mixture of glucose and fructose, as I've showed you their structures here in the grape. And those are actually coming from sucrose. Sucrose is a sugar and it's a disaccharide. It's literally, if you look at the structures on my screen of sucrose, you can see that it's literally a combination of glucose and fructose. If you join those 2 molecules together, you get sucrose. But what's happening is that sucrose is transported to the grape. And by the time the grape is ripened, the sucrose is broken down into the 2 main constituent sugars, which is glucose and fructose, by this enzyme called invertase. So at ripening, once the grape is very ripe, you have a 50-50 mixture of glucose and fructose in your grape. You can measure the sugar content of by using this calculation. We call it Brix. In wine industry, they call it the Brix, and it's the amount of grams of sugar you have per liter of the wine must. And there are lots of fancy instruments and techniques they can use to do that. A hydrometer is one instrument you can use to figure out how much sugar you have. And this is important for winemakers because if you know how much sugar you have before you do the winemaking process, you can calculate how much alcohol you're going to get, since the alcohol is directly related to the amount of sugar you have in your grape. And so winemakers know the percentage alcohol they're going to get in their wine before they even start the fermentation process by measuring the sugar content. Now we can talk about dry versus sweet wines. And a dry wine is really just low sugar content. And what that means is that not all of your sugar, as much or all of your sugar is converted to ethanol. That's when a wine is dry. A sweet wine, on the other hand, is a wine that has more sugar in it than a dry wine. And there are ways in which this can come about, right? It's determined, one, by residual sugars, which result from incomplete fermentation. So if the yeast doesn't convert all the sugar to alcohol, then you're going to have some sugar remaining and your wine's going to be sweeter. The other thing you can do is, if you want a sweet wine, you can stop this fermentation process before all of the sugar or a majority of the sugar is converted to alcohol. And that's what they do in a Moscato, which is why that is sweeter, is that they stop the fermentation through the process, and what results is a wine that has more sugar and it is sweeter. The same thing is done for a port, which instead of stopping the process, they actually stop it via adding brandy. They add brandy to the wine, which increases the alcohol content, and the sweetness stays behind, but also increasing the alcohol kills the yeast as well and shuts the process down. So there's another way you can have sugar content in your wine, and that's from these non-fermentable sugars that are at the bottom of your of the screen. These sugars are not fermented by your yeast, and so they stay behind. And that is why no wine is ever fully dry. There's no wine you'll ever drink that has no sugar in it. And that's because there's always a little bit of incomplete fermentation as the yeast die off as the alcohol content increases, but also the presence of these sugars. And these sugars are going to be in different quantities depending on the grape genetics. And these sugars will add some sweetness to your wine. But a huge other effect is the climate. Climate affects the sugar and acid content of your grape. So for example, if you're at cooler climates, what we've noticed is that you're going to have a lower sugar content with respect to acid content in your grape. And that's why wines from cooler climates typically are more zippier and higher in acid and are lower alcohol content because they have lower sugar. While on the contrary, wines from warmer climates are going to have higher sugar content. You can get higher alcohol as a result and a little bit less acid. Winemakers can manipulate this process by what we call chaptalization. And that is for the wines that have lower sugar, they can literally add sugar to the wine must before they do the fermentation. Just dump a bag of sugar, however much sugar you need, to increase your alcohol output to the wine before you do the fermentation. So these are ways in which winemakers can manipulate dry versus sweet during the process of winemaking. So next major component are the acids, and acids are very important. But before we talk about acids, what we should do is appreciate what acidity is. And acidity, of course, is going to be measured by chemists. We measure that on a scale from 0 to 14, where your highest acid, your strongest acids have a pH of 0, and your strongest base has a pH of around 14. What that means is acidity your acids are stronger with lower numbers. A lot of people have trouble thinking about it this way, but stronger acids of lower numbers, weaker acids of higher numbers. And so a strong acid would be at around 0. Battery acid is 0. Your stomach acid is 1, has a pH of 1. And wines have a pH at around 3 to 3.8. So white wines are going to be higher acid, which means lower pH, while red wines are going to be lower acidity, which means higher pH. So make sure you understand that. Lower numbers mean stronger acid, higher numbers, weaker acid. And just to compare that to some other things, lemon is pretty acidic at around 2, and a coffee is not that acidic at around 5, milk at around 6. And here are the 5 major acids that are found in wine. And what they are. What are they? They are tartaric acid. Tartaric acid is actually the major acid that is found in wine. Malic acid is the next major acid. And tartaric and malic are pretty strong acids. But malic has a really sharp bite to it that's not very pleasant, and can make your wine not very tasty. It's a little bit sharp. Lactic acid is softer and creamier. Lactic acid is found in dairy products, while citric acid has this intense sour taste. Acetic acid is present in your wines. It is very sour. Of course, we all know what vinegar smells like and tastes like. And it's also volatile, which means you're going to be smelling it. And so you don't want too much acetic acid. As a matter of fact, when winemakers measure their acids, they measure for volatile for acetic acid, which is a spoilage product of your wine. You definitely don't want that. And so how do you know something is an acid? It's an acid because it has this particular structure. If you see that carbon that's attached to the oxygen, that's attached to the O, that's attached to the H. That is how we know we have an acid. This is a functional group, we call it. Every acid, every organic acid has that group, and you can see that present throughout all of these 5 acids, this repeated structure. Tartaric acid has 2 of these acidic units, malic acid has 2 of these acidic units, lactic acid has 1, citric acid has 3 of these acidic units. So those are what causes the wine to be acidic, because that hydrogen on the end can be removed and increases the acidity in your wine. Now, how do winemakers control acidity? Well, they can do this cold stabilization process that I talked to you about, right? That decreases the acidity. Remember now, white wines are pretty acidic, and if you don't want your wine to be very acidic, you can remove the tartaric acid from your wine. And one way to do that is to do this cold stabilization. What you do is that you keep the wine very cold, and either the natural potassium salts that are present in your wine, or by adding a potassium salt, specifically potassium bicarbonate, you can convert tartaric acid into potassium bitartrate. The conversion of tartaric acid into potassium bitartrate creates this crystalline form of the tartaric acid, and that crashes out of the wine, effectively removing your tartaric acid from the wine and therefore decreasing the acidity in your wine. And you probably have seen this in your wine. If you've ever seen those crystals in the bottom, people call them wine diamonds. You see these crystals in the bottom of your wine, and that is potassium bitartrate. People usually say that the presence of potassium bitartrate tells that your wine is a great wine because there isn't so much intervention in the winemaking process, because clearly your winemaker hasn't taken the step to add compounds to it to remove the tartaric acid. So that's one way to reduce the acidity. Another way to reduce the acidity is to use this process that we call the malolactic fermentation. So after yeast converts your sugar into alcohol, you can then dump some lactic acid bacteria into your wine. And what that does is that does this really cool function where it breaks down the malic acid, that sharp tasting acid, into the softer, creamier lactic acid. And how it does it is by literally cutting off one of the acidic units from malic acid. If you look at lactic acid and look at the structure, that left acidic unit of malic acid is removed. So clearly then that serves 2 purposes. One, it's decreasing the acidity in your wine because you're cutting off one of the acidic units from malic acid that is converted into carbon dioxide. And also it's making the wine a little bit softer and creamier and not as sharp and unappealing as the malic acid decreases in concentration and the lactic acid increases in concentration. So this malolactic fermentation is done in most reds. And you can see why, right? If you do malolactic fermentation, you're decreasing the acidity, which means that you're getting into the range of acidity that people like for white wines, less acidic than whites, right? People like for red wines, which is less acidic than whites. But people also do this for Chardonnays. And the reason why they do this for Chardonnays is because they get this flavor profile that people like. It causes the Chardonnay to be what people call buttery. And how that's happening is citric acid breakdown by the bacteria. And what the bacteria is doing, in addition to converting the malic acid to lactic acid, is that it's converting citric acid to this compound we call diacetyl. And this compound has this odor profile that is very, very buttery. US Chardonnays are typically more buttery than Burgundy Chardonnays, and that's because they have really pushed this process in Chardonnays in the US compared to that in Burgundy. And so you have this more buttery flavor in your Chardonnays as well. All right, let's move on to another class of compounds, and these are the esters. What do the esters offer to wine? Esters are pretty much the compounds that are giving you the fruity flavors that you see in wine. You smell in wine. And ethyl acetate here is an ester that has a fruity flavor, but it's also the major component in nail polish remover, which means, yes, you are drinking a little bit of nail polish remover in some wines. Isoamyl acetate has that banana flavor, and these other esters have different flavors, as you can see on the screen/board: green apple, honey, caramel, coconut in these flavors. Now, esters look very similar to acids. You might notice that the esters have a very similar structure, right? Embedded in them. They have that carbon with that oxygen attached double bond, and they have that other oxygen that's coming off of it. The only difference between the esters and the acids is that the oxygen is attached to a carbon instead of a hydrogen. If we go back really quickly, you can see that these carboxylic acids have that oxygen that are attached to hydrogens, but esters have their oxygen at the end attached to other carbons. What this means is that esters are derivatives of acids, and there must be a relationship between the two. And that relationship is what I'm going to show you here. And it's a very important relationship that affects the wine. So let's take isoamyl acetate, for example. This is the banana flavor or banana odorant in your wine. And what can happen with esters is what we call hydrolysis, which means we're literally breaking the ester apart, breaking it into two pieces under acidic conditions. Remember now, all of these reactions that are happening in wine are because wine is an acidic medium. And so acid can catalyze this process where we can convert this isoamyl acetate into its two constituent parts, which is acetic acid and another alcohol. This reaction is reversible, meaning that the acetic acid can react back with the isoamyl alcohol and react together to condense together and give you back isoamyl acetate. So this is a reversible process, and that is happening constantly in your wine. Now, it's important to also know that these esters are primarily formed during the fermentation process. The action of the yeast upon your grape must is converting the alcohol, the carbohydrates into alcohol. But a byproduct of this process is that they're generating a lot of esters. And these esters are going to clearly have these unique flavor profiles, and that's going to be dependent on the yeast strain that you're using and as well as the grape genetics. And so you can get, for example, in a very fruity wine, you can get this isoamyl acetate. And then as it is stored after these are formed, you're breaking it down over time slowly in the presence of acid to acetic acid, for example, here, and this isoamyl alcohol. But then the acetic acid can recombine with another alcohol. And an alcohol that it could combine with is ethanol, which is the major alcohol that's present in your wine. And what that does is that it reforms a different ester. And that different ester is going to have a different flavor profile from the original ester that you get immediately after fermentation. And that is why people always say that your flavor profile changes from a young wine to an aged wine, because this process is one of the processes that are happening. And so young wines are typically more fruit forward, meaning that you can smell the bananas and the green apples pretty immediately as they're generated. And over time, the fruit forward nature of the wine changes as the wine matures and these chemical processes happen, and you form different esters that have different flavor profiles. Now, because of that, there's certain wines that suffer from this, and these are the acetate ester wines. Their odor profiles do not age very well, and that's because they're broken down and they form other esters that really change the flavor profile to the point where it's not as great as people like it when it's just made. And for example, Beaujolais Nouveau is one of those tropical fruity wines like Pinot Grigio and Sauvignon Blanc, and a Chardonnay that's aged in stainless steel. Those typically suffer from aging because of this ester hydrolysis. So moving on to terpenes and isoprenoids, that's another category of compounds that affect wine and its flavor profile. And they give it pretty floral, typically these floral smells. So when you have the rose and the hibiscus odors, that's really coming from these types of compounds. And these terpenes really have these hydrocarbon frameworks, a lot of carbons, and they have some oxygenation as well that's present in the molecule. So linalool is a compound that's responsible for what they call a floral smell. That's a lily of the valley. Lilac, you can get from alpha terpineol, citrusy smells and floral smells from geraniol. The only terpene or isoprenoid, I should say, that gives you something that's non-hibiscus, is really popular one, is rotundone. That gives you that black pepper odor to your wine. Now, I want to give you a really cool story about these types of compounds, how it's really important and how it's affected winemakers' recommendations for when you drink a wine. So a Moscato, for example, is typically recommended that you drink this wine very young. And that's because the terpene that's present in the wine, after storage in the bottle, it quickly because wine is an acidic medium, it quickly does this acid catalyzed cyclization reaction and is converted pretty rapidly over time into 4-terpineol, which smells like pine. So you don't want to drink a Moscato too late, because then it's not going to have the wonderful floral component that it has right after it's fermented. So you really are recommended to drink this one early, because it breaks down because of the rearrangement of this compound. While in a Gewürztraminer, it's recommended that you age this wine for at least about 2 years, because it gets better over time. And that's because the compound that gives its floral nature converts over time via another acid catalyzed reaction into another compound that's this 6-cis rose oxide that gives it that lychee smell that's very characteristic to a Gewürztraminer. And so in one case, it's good to drink it early, because the chemical process that's happening to these terpenes leads to an undesirable compound, while in the other case, it's preferential to hold the wine, because the wine gets better and more, and compounds that are preferred, for example, this lychee compound is pronounced over time. And the final category I want to talk about in your wine are these phenols and these polyphenols, which are the basis of tannins that we've probably heard about if you drink wine. And so phenols are primarily going to be found in red wines. And that's because these compounds, red wines are fermented with the grape skins and the seeds that are rich in these phenols and these tannin compounds. And you can also get your phenols and tannin compounds from your oak barrels. And that's why they'll store certain wines in oak barrels. Chardonnays are typically stored in oak barrels, so they can take on some of those compounds. And vanillin is an example of a compound that is present in your oak barrel. Resveratrol is a phenol that is present in wine. People like it for its antioxidant properties, as well as it's good for your heart. Caffeic acid is another phenol that's present, but it's really these high order phenols that are really cool and give tannins their structure. And there are these flavin-thiols, these flavanols, and the flavillum, which gives us its color. And they look very similar in structure. So I don't expect you all to see the differences in their structures, but they're very, very similar in structures, and they're very important to the tannin content. So let's talk about what tannins are. So tannins are really these polymeric polyphenols. And tannins really describe a specific function. And the function of tannins is really to tan animal hide, right? And in wine, it's really these polymeric polyphenols. It's the repeating subunits of flavin-thiols. So if you look on the bottom right, I showed you that on the previous screen. If you really just take that compound and have it connected to another one of itself, and then connected to another one of itself, and then connected to another one of itself, they're like repeating units. It's a polymer of these units. That's what we call a condensed tannin, and that is what is responsible for the astringency in wine. It's the buildup of these subunits. And so, of course, that can be undesired. It dries out your mouth. It binds to the salivary proteins, and it's bitter. And that's what gives the wine the astringency, all right? That can decrease over time as the tannins rearrange. They either build up by adding more subunits, and the more subunits they add, they drop out of the wine. They become more solid in nature, and they fall out of the wine. Or under acidic conditions as well, they can break down into smaller subunits, which are more palatable, right? These processes happen over a very long period of time. And this period of time results in the tannins. What people like to say is that the tannins get softer. And so high tannin wines include Nebbiolo, Cabernet Sauvignon, Mourvedre, and those wines are going to be typically recommended that you wait 10 to 15 years to drink them, so that the tannins can soften and can become more palatable. While a low tannin wine, a Pinot Noir or Gamay, are low tannin wines. And the reason why they're low tannin wines is because they have very thin grape skins, meaning they don't have high tannin content because of the thinness of their grapes. Those you can drink after a few years of aging. Instead of waiting 10 to 15 years. So the tannin content is definitely influenced by the grape, the skins, and also you can soften the tannins by aging, by letting the acid catalyzed reactions happen over a period of time. the final category of phenols are the anthocyanins, and they are responsible for the color, right? So they are present in the skin of the grapes, in the red skin. And so you can see the structure here, and I have them colored. There are different forms of this compound, and the forms of this compound are dependent on the pH. How acidic is the wine, right? So it is going to be a red pigment at pH that is of the pH that you drink wine. So between 3 and 3.7 pH, 3.8, your wine pH is going to be perfect for this to stay red. But it can turn basic, right? If you're under basic conditions, it will turn color and it will turn a blue-violet color if the pH increases or becomes more basic to around 5, it starts turning into blue. And then it will also turn colorless if you add things to this reaction, so to the flavillum. So things like water, sulfur dioxide or sulfurs, and other polyphenols, if they add into the flavillum, they will change the color to colorless, all right? And so that's one reason why they don't like to add too much sulfites. If you add too much sulfites to your wine, it'll make the color less red and more clear as well. And so this is really neat. And you might have observed this before. If you've ever had like a wine glass with a little bit of remaining, I know I always have this, a little bit of remaining red in your wine glass that you leave overnight on your counter, and then you add water to that. If your water is alkaline enough, you'll see that it turns into a blue color. And that's because the pH is increased and that pigment turns blue. The other time you might see the blue colors, if like me, you spill your wine glass when you break it a lot because it spills over onto your counter and you need to wipe it up. And then you spray some of your house cleaning products onto your surface and you wipe it down with a piece of paper towel, and then you look on the paper towel and it looks blue. That's because the compounds that are in the cleaning agents are basic in nature, and they're going to turn, that color is going to turn blue once it's in that basic environment. And so that's what influences the color, is the presence of these flavillum polyphenols in the skins that are carried through the winemaking process, particularly in red wines. So with that said, I want to wrap up by like using all of this information that we talked about to kind of see why wines have their favorite, have their particular characteristics. And so, for example, a dry wine like Barolo, it's gonna make sense. A bone dry wine like Barolo has a high alcohol content. If you look at the alcohol content on the screen of the Barolo, it's about 15%. Typically, you're gonna get higher alcohol content from a Barolo, 13.5 to 15%, with respect to a Pinot Noir, which has is not as dry, but has a lower alcohol content, and that makes sense. If you have less sugar in your wine, presumably all of your sugar is converted to alcohol, so you should have higher alcohol content. While a wine that is not as dry will have more sugars in it, but less alcohol content because that's not converted all the way to alcohol. To alcohol. Your sugar is not converted all the way to alcohol. Also, characteristics for Barolo is that they're very high tannin. If you look at this chart, Barolos have really, really high amounts of tannins, and that's why you wanna, if you wanna mellow it out, you can let it sit for some years with respect to a Pinot Noir that has medium to low tannins. Barolos have high acidity as well compared to a Pinot Noir, which doesn't have as much acids, and that's of course dependent upon the grape genetics. So all of those things I talked about, the dryness from the sugar, the tannins, we just spoke about the acidity from the acids, and that all can be manipulated through the winemaking process to select for types of flavors you want, characteristic you want in your wine. And so with that, I want to end with two of my favorite wine quotes. Julia Childs, "Wine is a living liquid." Hopefully you do agree and understand why wine is a living liquid. It's stored in your bottle, in your house, and it's under acidic conditions, and chemistry is continuously happening in your bottle, and compounds are continuously changing that are going to influence the taste of your wine. And this really funny quote that I have from Ben Franklin, which, "In wine there is wisdom, in beer there is freedom, and in water, there's just bacteria. So drink more wine." Thank you very much for listening to this webinar, and I'll be happy to take some questions and answer them to the best of my ability.
Thank you so much, Andre. That was a fascinating presentation, and I'm sure we all came away from it with a much better understanding of the role that chemistry plays in the production of wine. we do have a number of questions for you. The first is, sometimes people get headaches when they drink wine. Should they avoid wine that has sulfites?
All right, so sulfites is actually gets a really bad name for headaches with wine. And that's because the sulfites that are present in the wine actually is not what's causing the headaches. If you're allergic to sulfites, you're actually gonna break out in hives. That's how sulfites show themselves. And also, if you're allergic to sulfites, you're not going to be able to eat a lot of other baked products that have sulfites in them. Really what's happening where you're getting the headaches is the presence of tannins. The tannins are really what's causing the headaches, and also the presence of certain other types of proteins. Histamine that's present in your wine can give you headaches. So it's really just the tannins. And that's why you'll probably get more headaches from after drinking red wine versus white wine.
Well, thank you. You had mentioned that Côte d'Aron is your favorite type of wine. Is there a particular winemaker that you would recommend to people?
So Côte d'Aron is really not my favorite. It's my favorite blend.
Oh, your blend. Okay.
It's my favorite blend. My favorite, oh my God, it's really tough. My favorite wine, my favorite is Nebbiolo. I really like Nebbiolo a lot. Barolos and Barbarescos. I don't have a favorite winemaker for that. I would say for whites, I do have a favorite winemaker for Sauvignon Blanc. I like Whitehaven a lot. Thanks to Professor Schertzer, who introduced me to that one. Louis Jadot makes a really nice Beaujolais that I really like as well. But I've drank people always ask, what's your favorite wine? And to be honest with you, I like all of them for different reasons. Sometimes I want a very tannic wine. Sometimes I want something that's fruitier. I go for a Sangiovese. And sometimes I want something earthier with a more mushroomy type forest floor. So I'll go for a Pinot Noir. So it really just depends on my mood. And I would recommend people not really get attached to one particular wine. It's just to appreciate the different profiles that they all bring and just experiment with them.
Wow, that's terrific advice. Thank you. I have another question, and that was, we seem to get many questions about when you expose wine to air to improve its flavor and what's going on there chemically.
Okay, so chemically, oxygen is bad for your wine because it's going to oxidize your wine, and it's going to cause a lot of side reactions. Luckily, in red wine, that process is minimized because the polyphenols that are present, the tannins, they actually prevent oxidation, all right? They act as an antioxidant. They prevent oxidation in your wine. And so they kind of absorb the oxygen in combination with iron. Iron reacts with the oxygen, form peroxide. The tannins react with that and kind of trap the oxidation products. However, what's happening in white wine, you'll see oxidation products more often. And that's because the compounds in the wine, like aldehydes and other compounds, get oxidized further into like carboxylic acids, and then that makes your wine less palatable. So yes, oxidation is bad for your wine. White wines can last for about 5 days, open up to air. Red wines, can last for like 5-6 days. White wines, you don't want to really drink after 2 to 3 days because then the oxidation pathways become problematic. You're generating some compounds that you don't really want.
I see. Okay. But initially, when you when you're decanting your wine, that's when you want a little bit of that.
Yes, so the decanting process is also when a lot of people think that decanting the wine is what softens the tannins. That's actually not true, because as I mentioned to you before, the tannins, it really takes a long time for those tannins to break apart into their smaller units. That's an acid catalyzed process, and air really doesn't do that. What's really happening when you're making the wine breathe is that you're actually just allowing the volatile compounds like your thiols and your sulfur compounds to just leave the wine. That gives it this the flavors that undesirable flavors. So it's really just letting it breathe, and all of the volatile organic compounds that are undesirable are leaving. But your tannins are still present. They really don't soften up unless you let them age in the bottle.
Oh, okay. Thank you for making that distinction. Is red wine, it's normally touted as being healthier. Is it actually healthier than white wines? And do white wines have antioxidants? And why red?
Yeah, I think the reason why people think red wines are healthier is really because of the greater variety of compounds that you have present in the red wine, because they ferment it with the skins and the seeds. and so forth. And that's where all of the antioxidants are present. So one of the compounds I showed on you was a flavanol. I didn't talk about that compound. That's one of the polyphenolic compounds that has really rich antioxidant properties. And the grape actually produces those in the skin as a way to protect itself from the sunlight breaking. And you saw wines that are actually in warmer climates have a higher amount of those compounds, and they have antioxidant properties. So your red wine does in fact have a lot more compounds like your resveratrol and all those compounds that have antioxidant properties. So it is fair to say actually that your red wines do have a higher amount of compounds that will provide those types of properties compared to your white wine, just by the nature of how they are fermented.
Okay. Could you tell us your thoughts about the chemistry of cork taints and other white wine faults?
I see. So cork taints have, so there are lots of compounds that are present in the cork. I forgot the name of one of them. It's this phenolic structure that's an anisole that can get into your wine that can taint the wine, and other compounds that can leach into the wine from the cork over time. And so that's undesirable. People use different kinds of apertures like glass or like a screw cap to minimize that process.
Oh, okay. We had a few questions about the shutdown process.
So the shutdown process is great. Actually, when I spoke earlier about the acetates evolving over time, that's part of the reason why you have the shutdown process. Also, the terpenes, as they rearrange, that impacts it. So I think what we have to appreciate is that right as the wine is produced, it's going to have a particular flavor, right? And all of the fruity esters that are present are going to be there. But as the wine transitions, meaning the esters are breaking down, they're going to have an intermediate stage where it's not going to taste as good, because, for example, if you're breaking down these acetate esters, you're going to have acetic acid, which is not desirable. So it has this weird period, which could last for years, where you're making these intermediate compounds that don't really make the wine taste very good. But as it ages, they start to reform new compounds now that gives it a whole new flavor profile that turns out to be so much more appealing. So there's this period, I would say, for some wines between like 2 to 3 years after they're bottled, that they're just not very good for like sometimes up to 5 years. And then they start coming to life again as the tannins break down and get softer, the terpenes rearrange, the esters reform, and now it gives it this vibrant new bottle of wine that tastes pretty different from what it was right after it's bottled. And that's why sometimes, a Barolo is aged for 5 years. They will not, you won't really get a Barolo for younger than 5 years, and that's because they, the optimal tasting, optimal flavor profiles don't start to come out until 5 years plus. But really, later to like 15 years is really when people start thinking that the Barolo is ready to drink.
Now, if you get maybe even farther down the line than that, why do old reds sometimes lose their color over time?
Well, that's why the reds will lose their color because actually of these side reactions that are happening. So when oxygen leaches into your bottle through the cork, or just naturally oxygen on the top of the bottle when it's bottled, all these oxygen pathways are happening. The phenols are actually trapping the oxygen. And if any of these sulfates, as well as I mentioned earlier before, add into the anthocyanins, the anthocyanins become colorless. And so the color will change because the anthocyanins are converted, are reacted with by your polyphenols that are present in your wine. They're reacted with by the sulfites that they use, and also the oxygen that's present in the wine that gets trapped by the polyphenols also cause other side reactions that react with your anthocyanins that affects the color of the wine, because you're losing those anthocyanins due to these side reactions.
Okay. This is a different sort of question, but it seems if we go back, history seems filled with stories of wine being consumed. And it seems like making wine is a very complex process. And before technology, way back when, how did people go about making wine?
That's a good question. I can't tell you anything before the 1800s. And really, they would just literally have the wine. I guess natural winemaking is it's funny because people talk about natural wines and they're like, oh, I want a natural wine. But natural winemaking is really how wines used to be people used to make wine, and that really is with little influence from humans, right? So you would just take your grapes, you'd crush them by feet, people would literally stomp on them, and then you would put them in a container and you'd let the natural native yeasts, wild yeast, just do the process. And then you'd filter that off and you would have wine. People nowadays have gotten very, very much into like making wine very consistent. They want a consistent flavor profile. People who are buying wine want to know that this is a wine that I've had before. It's reliable. And so the intervention at all of these stages of the winemaking process has increased. And a lot of people have been taken aback by that, and I've actually been very unhappy about the increasing influence of genetic modification of the yeast to pull out specific flavors, to the point where you are actually genetically engineering a wine versus letting the wine present its natural like flavors. And so that is what I would say would be my understanding of how wine was fermented earlier. But now it's way more complex, and people are getting into some really fancy technologies.
So going from way back when to the newest, have you heard of a bright blue wine from Switzerland? And
I have not actually heard about bright blue wine.
I haven't heard of that
need to add that to my list
Okay.
of things to learn.
Yeah, that was new to me too. Also, there was a question about plum wine and honey wine.
Plum wine. Oh my God, I knew this. Plum wine and honey wine. I'm gonna have to, oops. Why am I think I had something written down. I cannot speak to plum. I did read up about plum wine and honey wine. I do not remember exactly what they are, but I did read about that a few weeks ago.
And fortified wine or sherry, how is that different than the wines that we've been talking about today?
So literally just adding alcohol to that.
Oh.
And so
add a little more.
Yes. So like the ports and so forth.
What drives the price of wine?
Vintage is the biggest factor, I would say, that drives the price of wine. If you, so certain years are better than others. And that's because of the climate of that year. People were like, that's a good year because the climate was perfect. For example, in Burgundy, where they might get, your grapes could get frostbite if it gets too cold. The amount of sugars and acids aren't necessarily in balance that particular year. So if the weather was perfect that year, then people are like, the wines we made from this grape that year were just really good. So everybody wants that one. So that really drives the price of wine. And of course, the age, right? So if you have a wine, for example, a Barolo that people like to drink older, if you've stored it for 15 years, it's going to have higher value because that's the flavor profile that people are searching for. So I would say those are the vintage really is, and the specific year. So there are charts online that you could look up that tell you what year to drink what particular wine. Like these are the years that are great for wine, and these are the ones that are really bad.
Awesome. Well, it's great that we had time for these questions. I think they added a dimension to our discussion, which is wonderful. So thank you to those of you who posed questions, and thanks to all of you who participated today in this class. This class has been recorded, so you will be able to access it again. Many, many thanks to Professor Isaacs for sharing his time and his expertise with us today. This ends our Classroom Revisited event for this year. Please be on the lookout for upcoming alumni and parent programming in the next weeks and months. And in the meantime, have a good day.